Hello friends, today during class so many people had doubt on how to get the parity bits, so I am here with a video. Tada! Okay, so generally we use a 7-bit Hamming code. Okay, generally a 7-bit Hamming code. Say for example, my data is 1001. You are going to transmit this data to some other device, so we will not transmit that 1001 directly. We will do something, so we will add some extra bits and we will transfer it. So those bits are called parity bits. Okay, so if I told you generally we use 7-bit data, so 7-bit Hamming code. So now our data is 4 bits, so the remaining are 3 bits, right? So 4 plus 3 7 bits. So let me make boxes for it. So let me make proper boxes. 3, 4 and 5, 6 and 7. So here are my 7 bits which I am going to transfer. So in this my 4 bit should be my data, others are parity bit. So now how to identify what are the parity bits? Okay, so we'll be starting from the right. So from the right, this will be the first position, this will be the second position, third position and so on. Okay, let me write it for you. 6 and 7. Okay, so every number with 2 power 0, every position with 2 power 0, I mean 2 power n, 2 power 0, 2 power 1, 2 power 3, all will be parity bits. So for this example we need 3 parity bits, right? So number 1, this will be P, okay, I'll write it here. This will be P1 and this will be P2, and next thing 2 power 0, 2 power 1, and next will be 2 square, which is 4. This will be P, not 3, it will be 4. So okay, generally we refer to the position, so it will be P4 directly, and this other 4 which we have are the data bits. So we will not write like D1, D2, D3, D4, so we will just make the position for it. Okay, so the position for this will be D3. Okay, then this will be D5 and this will be D6, this will be D7. Okay, so how you will be writing your data is like this: 1 0 0 and 1. Okay, so now this is 1001, and let me write it here below: 100 something 1 something something. So this is your Hamming code which you will be transferring. But how to find these data? Okay, so this is P1, P2 and P4. How will you find? So there is a trick, not a trick, there's a formula to find. So P1 is equal P1. When you see P1, you should see D3, D5, D7. You just have to remember it. Okay, so the thing is, you see D3, D5, D7. So my D3 is 1, my D5 is 0 and my D7 is 1. So if we have even number of bits, so even number of ones, so how many ones do we have? 2 ones, right? So we have to make even number of ones. We have 2 ones here, 2 ones. So what should I add? What should I add so that the number of ones are even? So how many ones? So generally I'll tell you again. How many ones should I add so that the number of ones become even? It's already even, right? So we don't have to add any ones. So P1 should be 0. Okay. Yeah. Now see for P2. P2 will be D3, D6 and D7. And now my D3 is 1, D6 is 0, D7 is 1. So what should I add so that the number of ones become even? So already 2 ones, so even ones. So I don't have to add, that means 0. Now see for P3. P3 is D5, D6 and D7. And so D5 is 0, D6 is 0 and D7 is 1. So see, in this case I have 1 ones. Okay, let me repeat, I have 1 ones. So now you have to make even number of ones. So you have only 1 1. So to make even number of ones, you have to add another 1, right? To this you have to add another 1. So my P3 should be 1. Okay, so if I add another 1, so these becomes even. So see these 4 bits. So even ones, and here too these are even ones, and here too they are even ones. So that's how we find parity bits. So let us put this inside this. Okay, I think I told you P4 is P4 is 1, otherwise both are 2. my P4 is 1, both are 2. Okay, so this is our parity bit. So what the problem with the application was, it was reverse. Okay, so this thing was inverted. So how it looked was, it was 0 0 1 1 0 0 1. So this is how it looked in the application. This is the simulation page, and let me give 1 0 0 1 this time. 1 0 0 1 and okay, 1 0 0 1, 1 0 0 1 and 1 0 0 1. So MCQ, let me select, it became correct. Okay, minimum return is 3. Okay, so I guess you know this, right? So select the bits for parity positions. So 1, 2 and 4, that's it. Okay, next, how to solve this? And just now we solved 1 0 0 1 for parity bit, and this is in reverse. Okay, so it's 1 0 0 1, and our parity bit was 0 0 1 1 0 0 1, right? 0 0 1 1 0 0 1. So let's change all these to 1 and hit submit. So it's correct answer.